In this video, we are going to talk about sketching graphs of cubic polynomials. Well, cubic polynomials are written in a general expression, and that is ax to the power of 3 plus bx to the power of 2 plus cx plus d is equal to 0, okay? And whenever we factorize this polynomial, we can rewrite it again in this form. It will be equal to, let's say, x minus alpha times x minus beta times x minus theta, let's say, okay? And these alpha, beta, theta are the roots of this polynomial, okay? And this curve of polynomial, because it's a curve, it's a graph, it has two shapes, okay? It has two shapes. Either it is in this way, okay, or something like this. That means if on x and y axis, if we sketch this graph or plot this graph, it will be something like this. And it continues, it goes to infinity, okay? This is number one. So let's say number one. And then the next one, which is number two, will be something like this. X and y. And it will be something like this. It continues here and continues there. So if we look carefully at these two styles or two shapes, we will realize that if we, let me erase this part. In number one, in shape number one, as x, the value of x here increases, approaching positive infinity, we will see that the curve, the value of y also goes up. It also continues to positive infinity, approaches positive infinity. And when the x, the value of x, approaches negative infinity in this direction, the value of y also here will decrease or increases towards negative. It moves towards negative infinity. But in the second shape, as you see here, as the value of x approaches positive infinity here, you will see the value of y approaches negative infinity, okay? So the value of y here will be towards negative infinity. And similarly here, as the value of x approaches negative infinity, we will see the value of y here approaches positive infinity, okay? So this is the difference, the only difference, and we will find out in the example that I'm going to solve. We will understand what it means. But this is not the only information we need, piece of information we need. We need some more information, detailed information, to be able to draw this graph or sketch the curve. It's not only to know which of these two are and then randomly we just sketch. We need some more information, and the first information we need to know is where this curve intercepts x-axis. As you see, the curve intercepts x-axis at 3 points, 3 values, and these values are in fact the roots of these polynomials. Okay, so we can simply say alpha, beta, theta. If we factorize this polynomial, let's one more time have a look from the beginning. If we factorize this polynomial to this form, the roots of the polynomials in fact are the points at which this curve, okay, intercepts x-axis. Okay, so this is the thing we need to know. And also this curve intercepts y-axis. Okay, and we also need to know the value of this point. In order to find the value of this point, so okay, again one more time, let's review what we have done. So we know that this curve intercepts x-axis at 3 points, and if it doesn't have any repeated root, which in that case it will be tangent to the x-axis, but normally it intercepts at 3 points, and then these 3 points are the roots of this polynomial. We need to factorize and we need to just find the values of x. But in order to find the point at which this curve intercepts y-axis, we need to have a look at the polynomial and we need to substitute x by 0. We need to put x 0, the value of 0, because, and the reason is because, as you see on the y-axis, the value of x is equal to 0. So when the value of x is equal to 0, the value of y is exactly the point at which the curve intercepts y-axis. Okay, so in order to find this, we would say this value will be equal to y0. That means instead of x we need to write 0, and then we put 0, and then we will find the value of y. And also the third one, we need to check whether the x and y both approach positive and negative infinity, which in that case it will be shape number 1. And if x approaches positive infinity and y approaches negative infinity opposite each other, this will be shape number 2. Okay, so let's consider the example. It's the simplest one here, and we will get more idea, and then the next example I will solve the problem and I will sketch the graph. So in this part, in this exercise, this curve is given. Okay, the curve is given, and also the polynomial is given, and if you look carefully, polynomial is also already factorized, it's simplified, so we don't need to factorize it anymore. So it's quite easy, and we want to find the value of a, b, c, where curve intercepts x-axis. So in order to find the value of this a, b, c, we need to find the roots, and the roots are, as I explained earlier, we need to just set each equal to 0. So x minus 2 is equal to 0, x plus 1 is equal to 0, x minus 3 is equal to 0, which in this case x will be equal to 2. Okay, this is number 1, root number 1, and the next one, x will be equal to negative 1, and the last one, x will be equal to 3. So this is the third root. All right, so now we just compare the values with the curve, and we see the only negative one which is the smallest value, is a, which must be -1, and also the largest value of root is 3, so therefore c must be equal to 3, and also b, which must be 2, which is smaller than c. Okay, and this will be 2. That's it. But we also need to know the value of this d. What is the value of this d? In order to find that value, we need to, as I explained earlier, we need to write it in this way: y0 is equal to what? So we substitute x with 0. Therefore, it will be 0 minus 2 times 0 plus 1 times 0 minus 3. And we need to multiply. -2 times 1 will be -2. And -2 times -3, it will be +6. So therefore, d will be equal to 6. Okay, so that's it, and this is the answer for this question. But the next problem, we need to sketch this graph. Okay, in order to sketch this graph, we need some informations and some steps to take. So step number 1 was to find the roots. What are the roots? So this polynomial has already been factorized and simplified, so that's quite easy for us. We just need to set each parenthesis equal to 0. So therefore, x minus 2 is equal to 0. X minus 4 is equal to 0. X plus 2 is equal to 0. Therefore, here will be x will be equal to 2. X will be equal to 4. And x will be equal to -2. So these are roots of the polynomials. That means at these points, the curve will intercept the x-axis. But we also need to know where it intercepts y-axis. And in this case, we need to find y0. So y0 means we need to put the value of x 0 here. 0 minus 2 times 0 minus 4 times 0 plus 2. And that will be 8. -2 times -4, +8 times 2, 16. Okay, this will be 16. And also we need to know whether it's the shape 1 or shape 2, because we already had we also had 2 polynomials. Okay, we had 2 polynomials. So in order to find this value, we need to determine the shape. We need to just say step number 3, which is if x approaches positive infinity, then what will happen to y? So then we need the original or the factorized polynomial form, and then we will say, let me write here, y will be equal to positive infinity minus 2 times positive infinity minus 4 times positive infinity plus 2. What I have done is I just replaced x in the equation by infinity, positive infinity, but. So now let's simplify. Positive infinity minus 2 will be equal to positive infinity. Okay? Times positive infinity minus 4 again, positive infinity, and then positive infinity plus 2, also positive infinity, because these values will be added or deducted from infinity. They don't make any difference. So therefore, we have this infinity, positive infinity times positive, and the answer will be equal to positive infinity. So therefore, y also approaches positive infinity. Here I can now be sure that the pattern will be number 1, which is in this pattern, okay, number 1 here. Because x approaches positive infinity, y also approaches positive infinity, okay? That's it. And now I need to just draw the graph. Okay, let's draw the graph. This is y and this is x-axis. So then I need to mark on the x and y axis the roots and the points. So here let's start with -2. This is 1, and then next one will be 1 and 2, okay, and the next one 3 and 4. This is 4. So as you see, 3 points which are the roots, and these are the points where the curve intercepts x-axis. So let's one more time, I will draw the shape in case I forget. So I'm going to draw this shape. So this shape comes from negative infinity. This curve gets into 1, okay, and then goes up, and then it also needs to intercept the y-axis, which here will be equal to 16. Let's say here is 16, okay, and then goes up and then comes down and enters the next root and then exits the last root from here. So this will be the point of exiting. This will be exit. Here will be entering, okay. So this is the situation here. Now let me now draw the curve to see. Enters from here, goes up, and then cuts, okay, then cuts the or intercepts the y-axis and then gets into 2, and then gets out. Okay, so that's it. This is how it is. And also, if you want to find the value of what is the value here, how far it can go to the negative or how far it can go up or down, we need to just simply find the average x here. Average x here is 3. Average x here is 3. So if we put the value of 3 instead of x in this equation, in this polynomial, we can find the value of y here, and then we can also identify how low it can go to negative. Y or curve can go to negative. And also here similarly, we need to put the value of x is equal to -1 to find how high this curve will go. Okay, now let's do another example. So we have another polynomial here, and we need to take the steps. So step number 1, what was that? Roots. Yes, roots. We need to find roots. So in order to find roots, we need to set each parenthesis equal to 0. So we'll say 3 minus x is equal to 0. X minus 1 is equal to 0. X plus 2 is equal to 0. Here we will get x is equal to 3. Here we will get x is equal to 1. And here we will get x is equal to -2. So these are the roots of this polynomial, as you see, okay? And also step number 2 was to find out where it intercepts y-axis. In order to do so, we need to find y0, which means we need to put 0 instead of x. It will be 3 minus 0 times 0 minus 1 times 0 plus 2, which will be equal to 3 times -1, -3, -3 times 2 will be equal to -6. Okay, so this is a value of the point where the curve intercepts y-axis. And also step number 3, I need to make sure if the curve is shape number 1 or shape number 2. In order to do so, we need to say if x approaches positive infinity, what will happen to y? What will happen to y? Then I need to write the equation again here. Y will be equal to 3 minus infinity. Okay, instead of x, I just put infinity here, times infinity minus 1 times positive infinity plus 2. Okay, and here, as we see, 3 minus infinity, we have negative infinity here. So negative infinity, let me rewrite it. This parenthesis means it's like that, negative infinity plus 3, which again will be equal to negative infinity. Okay, so this parenthesis, we have negative infinity, positive infinity minus 1 will be equal to positive infinity. Also positive infinity plus 2 will be equal to positive infinity. So negative infinity then multiplied by positive infinity multiplied by positive infinity will be equal to negative infinity, because we have one negative. Okay, one negative times two positives will be equal to negative. So therefore, here I can say, therefore y approaches negative infinity. In this case, I'm supposed to draw the graph with style number 2, which is here. As you see, if x approaches positive infinity, then y approaches negative infinity. So here is the shape number 2. Okay, so therefore the shape will be something like this. I will draw the here for myself to avoid forgetting this shape. Okay, now I need to draw the graph for x and y axis. So this is x and this one is y. So now I need to mark the roots. Roots are 3, 1, -2. So let me start with -2, 1, 2, and 3. Okay, and then we have also another point, which is -6, which -6 is where this curve intercepts the y-axis. So here will be equal to -6. Okay, so this curve, in fact, here enters. So this is 3, 1, and also -2. So these are the roots, and here also. Okay, so this curve enters from here, goes up, and then comes, intercepts y-axis, and gets out from here. Here will be in, getting in, and from here getting out. So let me draw it. It will be something like okay, it will be something like this, and that is the curve. And again, this is the graph. And again, if you need to, if you want to make sure how high it can go, we need to just put the mean the value of x as 2, because 2 is between here. Yes, 2 is exactly below the peak. Yes, and also similarly here -1, and then we can find the value of x. If we just substitute x as, for example, 2, we can find the value of y there. Okay, here. All right, this is the end of this video, and this is how we can plot the graphs of cubic polynomials. Thanks for watching this video, and please like and subscribe if you find this video helpful.